Why is the initial mass function important for stellar nurseries? Imagine a cosmic nursery where stars are born from swirling clouds of gas and dust. This is what scientists call a stellar nursery. But have you ever wondered how many small stars versus big stars form in these regions? That's where the initial mass function, or IMF, comes into play. The IMF is a way to understand the distribution of star sizes right at the start of their lives. It shows us that most stars born in these nurseries are actually small, low-mass stars, while only a few are massive. This pattern is important because it influences how galaxies grow and change over time. Stellar nurseries are dense clouds filled with gas and dust. When gravity pulls this material together, stars begin to form. The IMF helps scientists predict how many stars of different sizes will emerge from these clouds. Knowing this helps us understand the overall process of star formation and how galaxies evolve. For example, high-mass stars burn brightly and live short lives, ending in supernova explosions that spread elements into space. Low-mass stars, like our Sun, burn more slowly and can last billions of years. This balance affects the chemical makeup of the galaxy and the planets that might form around stars. Understanding the IMF also helps us figure out how fast stars form in different regions. If a stellar nursery produces mostly small stars, it might mean the environment is less energetic. If many big stars form, the region is more active and can influence nearby clouds through radiation and stellar winds. This feedback can either trigger more star formation or slow it down. From a larger view, the IMF links tiny star-forming regions to the big picture of the universe. It helps us understand how galaxies gather mass and how elements necessary for life are created. For policymakers, studying the IMF supports decisions about funding space missions and telescopes that observe star formation. These investments lead to new discoveries and technological advances. In short, the initial mass function is a key tool that reveals how stars are born and how they shape the universe. It guides scientists in understanding the life cycles of stars, the growth of galaxies, and even the potential for planets and life beyond our solar system. Knowing the distribution of star sizes from the very beginning helps us see the bigger picture of how the cosmos develops over time.